Okay, this video is about applying properties of similar triangles. And this objectives today is to use the properties of similar triangles to find segment lengths and to apply proportionality in triangle angles and the triangle bisector theorem. So really all the problems today we're going to do have this in common. We're going to set up the problems using proportions. Okay, and then we're going to be able to cross multiply in order to solve. So the theorem that we're looking at here is when a line cuts through a triangle parallel to one of the sides. So when we have a line parallel to one of the sides of a triangle. If a line parallel to the side of a triangle intersects the other two sides, then it divides those sides proportionally. So what that means is the pieces of the sides that are cut here are proportional. We can make a proportion out of them. We can take these pieces, like the red piece over this red piece equals this green piece over this green piece. And that's what they're saying right here. We can break it down like that. So now that is only true if the lines are parallel. Now this theorem also works backwards. If we try the ratios first, okay, and we discover that the pieces on one side are equal to the fraction of pieces on the other side, then that means that the lines are in fact parallel. If a line divides two sides of a triangle proportionally, then it is parallel to the third side. So let's look at an example of this. All right, this example asks us to find US. So we can see in this picture that the two lines here are parallel. So what we have to do is make a fraction of the two sides using the pieces that go together and the fraction of pieces on this other side, and then we'll be able to cross multiply to get the answer. It is given to us that ST equals UV. So this should actually say that ST is parallel to UV. It's given to us that these two lines are parallel. So we're going to make a fraction of their pieces. SU right here over RU, which is the 14, equals VT, the 4, over the RV, the 10. Okay, and that is by the triangle proportionality theorem. So we're going to take this ratio that we have right here, and we're going to plug in these numbers that they give us in the problem. So now we have US over 14 equals 4 over 10. So those numbers are right here from the picture. Now we can just get the answer by cross multiplying. Multiply on one diagonal, 4 times 14 will equal multiplying on the other diagonal, 10 times US. Okay, so to get the answer, we simply divide by 10, and we get 56 over 10 for our answer, or 5 3/5. So now, in this one, they've asked us to go the other way around. They did not tell us that these two lines are parallel. If they're going to be parallel, then we need to make sure that the sides are proportional. So we need to check one side. The pieces here would be the 10 and the 15, divided by the other side, the 8 and the 12, and see if they're equal to each other. So AD over BD is 10 over 15. That reduces to 2/3. Also, AE over CE is 8 over 12. That also reduces to 2/3. So since the two pieces are equal to each other, the lines DE and BC must be parallel by the converse of the triangle proportionality theorem. All right, and then we have that and now we have that what if we have three parallel lines? Well, if three parallel lines are cut by these two transversals, the pieces of these lines are also proportional. So the piece right here, AC, over this piece CE equals on the other side this piece BD over the next piece BDF. So let's try an example of that. Here, suppose that an artist decides to make a larger sketch of the trees in the figure. in the figure, AB is equal to 4.5, BC is 2.6, and CD is 4.1. KL is 4.9. Find LM and MN to the nearest tenth. So what we're going to have to do here is take the pieces of these sides, the 4.5 here on top and the 4.9 on bottom, and make a fraction of them, 4.5 over 4.9, and then we'll do the BC here and the LM. We'll find LM first. So we're given that all these are parallel. So we're going to do KL on the bottom. KL corresponds with the KL over MN, and then on top we have AB over BC. So we plug our numbers into that, and we have 4.9 over LM equals 4.5 over 2.6. Now we could have set this up differently. We could have put 4.5 over 4.9 and then 2.6 over LM. So when we're setting up proportions like this, there's more than one way to set it up that gives us the right answer, just as long as you get the same thing when you cross multiply. All right, so let's go ahead and cross multiply. Okay, and we're going to get 4.9 times 2.6 equals 4.5 times LM. Okay, dividing by 4.5 on both sides, and our answer is approximately 2.8. All right, and one last type of problem. Oh, I'm sorry, we have to find the other piece. So they also asked us to find LM, or MN. So to find that, we're going to use the same ratio that we had before with the KL and the AB. Okay, so we're still going to use KL and AB, but this time we're going to use MN and CD. Okay, so plug in the numbers they give us for that. And when we cross multiply, we're going to have 4.5 MN equals 4.1 times 4.9, divide by 4.5, and our answer is 4.5, approximately 4.5. Okay, so there's one last type of problem that we want to look at, and that is the angle bisector. Whenever we have an angle inside of a triangle, an angle bisector of a triangle, it divides the sides opposite the side into two segments whose lengths are proportional to the two sides. So what this means is that we can have a fraction like this: red 1 over the red one equals the green 1 over the green one. So again, you take the pieces of the sides and you make a proportion. Then we'll be able to cross multiply to get the answer. So here's an example of that. Here I have these pieces of sides. First of all, let's figure out what pieces we have that we can make our ratio out of. We have PS, okay, over SR, which is the two pieces of this side, equals the QR over, QP over QR. Okay, so when we plug into these values, okay, we have a slightly harder problem here to cross multiply and solve, but we can do it. So 40 times x minus 2. Don't forget to put parentheses around that x minus 2 when you cross multiply. And 32 times x plus 5. Don't forget to put parentheses around that x plus 5, because the 32 is actually being multiplied to that whole thing. And the 40 is being multiplied to this whole thing. So then we'll have to distribute the distribute the numbers on the outside. Combine our like terms. Let's see, this is what we have now. Combine our like terms. Okay, and then divide by 8. So the answer is 30. Now the question asked us to actually find the length of those sides, so we have to substitute back in for x. So PS here is x minus 2. So 30 minus 2 gives us 28. And SR is x plus 5. 30 plus 5 gives us 35. Great job.